Konnichiwa. Hello, my name is Allan Friedman. I'm incredibly sorry that I can't be with you in Tokyo today. Uh, Unfortunately, I had to, at the very last minute, cancel my trip to Japan. But I'm very honored today to talk with you about the emerging, evolving shape of software security. So let's do the awkward thing as I slowly pull up my slides. And hopefully everyone can see it. So today, we are going to be talking about SBOM and security transparency and how it all fits together. My name is Allan Friedman. I am from the United States Cybersecurity and Infrastructure Security Agency, sometimes known as the guy who does not shut up about SBOM. So today, a better title for this talk might be some of the challenges of building the plane while flying it. Now, what are we going to be talking about today, and why should I watch a video rather than actually talking to colleagues? So we're going to do a very quick reminder of what an SBOM is. We're going to talk about why it's actually going to impact all of us across the software and security world. We're going to talk about some of the challenges that SBOM has as we make it a reality. But the core here is going to be talking about how this relates to some of the other pieces. So we're going to be talking about how do we identify the known badness with coordinated vulnerability disclosure. We'll be talking about challenges of software identity and things like VEX, where we need to figure out what's effective. And then we'll zoom into what the big picture is. So for those of you who are not familiar, I run the SBOM program for the US government, working with people around the world, including a lot of great experts here in Japan, to understand the future of software bill of material. So why are we focused on this in the first place? Well, we know that risk is just changing. It's slowly growing, right? The number of vulnerabilities increases every year. Not going to go down anytime soon. And similarly, we know that attackers are not just going after vulnerabilities that naturally occur, but they're actively attacking the supply chain. Now, the supply chain you can think of as the underbelly, the soft belly of cybersecurity. It's not as well defended, usually an internal issue, and we forget that it's exposed. And by the way, yes, this is an excuse for me to put a picture of my dog on the slide. When we think about supply chain risks, there are a lot of them. And it ranges from vulnerabilities to intentional attacks to risks of just not having enough open source maintainers, end of life software, or even just the reuse of code that shouldn't be reused in different places. And so one core path forward is the question of transparency, thinking through learning what is actually in our software. Now, I like to use the analogy of a list of ingredients. One of my favorite candies in the world is a Kit Kat flavor that I can only find in Japan, peach flavored Kit Kat. And this fun treat comes with a list of ingredients. And for me, it's insane that we expect more transparency out of candy than we expect the software that runs our companies, our governments, our critical infrastructure. Now, software transparency won't solve all of our supply chain concerns, but any solution that we are going to have will start with transparency. And so again, if you're not familiar with an SBOM, it's not a very complicated idea. It's this list of ingredients, which for software takes the form of a tree. So in our toy example here, Acme application has two dependencies, bingo buffer and Bob's browser. Bob's browser in turn depends on suppression engine. For each of these components, we don't need that much information. The supplier, what's the component, what are the versions, what are some of the identifiers, and where did this data come from? Now, in a little bit, I'll talk about how some of these are a little more complicated, but the basics are pretty simple. And we need this data for proprietary software, for open source code, for in-house developed modules, for built binaries that I'm using. You want it from across the board. Why do we need it? We need it for a range of concerns. Depends on where you are in the software ecosystem. Many of us make software. It's difficult to say that you have a secure development process if you don't know what's in your software. Some of us choose software. We buy software for our organization, or we select open source projects. And to make that decision well, we need to think about the supply chain. We need to think about whether or not there are known vulnerabilities already in there. And some of us operate software. And for that, we need to be able to respond quickly and cheaply when a new risk comes along. So vulnerability management requires a view into the supply chain. If you were running software when Log4j reared its head across the global ecosystem, and SBOM made that cheap and easy to deal with. If you didn't have it, you spent a lot of time working. Now, this isn't just a good idea. It is something that is going to be coming towards us through regulation and compliance. And it's happening around the world. In the United States, we have an executive order that said everything the government buys is going to have SBOMs. Medical devices are going to have an SBOM. The United States just announced that connected vehicles, cars, are going to have SBOM. But again, this is something that is happening around the world. In India, the Security and Exchange Board has announced SBOMs are important, and the National Cert is created technical guidance. In Japan, one of the first countries to do some public guidance on SBOM, they're now on version 2 of their SBOM guidance. And my colleagues at the Ministry of Economics, Trade and Industry have done an amazing job. And perhaps the biggest thing that's coming towards all of us is the European Cyber Resilience Act. This is a regulation that will cover all digital goods sold in the entire European Union. So this SBOM is going to be part of our regulation. Now, one of the challenges is how do we think about what those definitions are? How do we make sure that the data about the supply chain is actually good? Do we need the complete list, or do we have an incomplete list? How do we think about ambiguities in technical specifications or deal with data coming to us from multiple sources? Not all of the free tools that many of us currently use are of actually good quality. There's some great work out of southern Italy that said, listen, the things that we often use, like GitHub's dependency graph, may not give us the full amount of information that we need. And for proprietary solutions, I mentioned medical devices have to have SBOMs. Yet when I talk to someone who works for a company that makes the blinking box that is keeping someone alive in a hospital, they say, hey, listen, none of the tools that we can buy on the market, and there are dozens of SBOM tools out there, but none of them meet the needs for something as specialized and critical as a medical. So one of the things we need to do is to come together and have better definitions of SBOM. Thinking about what are the data fields we need, thinking about where in the lifecycle of software it's defined, and we need to build that based on use cases. One thing that we're doing at CISA is making sure that that set of definitions is harmonized globally. We're working with our colleagues in Japan. We're working with our colleagues in Korea, in Singapore, in Taiwan, in India, to make sure that we're all on the same page when we're defining SBOM. But it's not all just about defining one concept. SBOM touches on many other aspects of software. One challenge is how do we think about software identity? The quote by Phil Carlton, the original author of Netscape, is there are only two hard things in computer science: cache invalidations and naming things, and off by one errors. And I'm going to assume that everyone in the room laughed at that little computer science joke. But the identity is really hard. Do you call something Windows_10 or Windows-10? Well, it's easy if you and I are just talking. But if you're trying to use a simple, direct linear matching algorithm, you're going to have a bad time. We collectively need to do a better job of understanding naming. And the solution isn't just everyone in the world should do what I do. That's not going to have you a good solution because, of course, it doesn't scale. Last year, CISA published a paper on software identification ecosystem, where we identified the solution is to move to a world where we have multiple software identifiers. Today, we use something called CPEs for vulnerability records. We're going to want to think about including pearls, think about using a hash-based solution like the software heritage ID, or like a new thing that's being developed called Omnivore that we're working on here at CISA. The next thing we need to do is take a step back and say, well, where are the vulnerabilities coming from? SBOMs are really good at identifying what you do when you are aware that there is something bad in your software. Where do those bad things come from? That comes from coordinated vulnerability disclosure. What are the steps there? Well, the most important one is research, the great work that you do finding vulnerabilities. Then there's a reporting step. Researcher reaches out to the organization. Then the organization that makes or maintains the software has to acknowledge it. That yes, thank you for flagging this. This gets complicated for things like open source. Who does that work? Who do you work with? Then you have assessment and validation, remediation, and finally, public disclosure, where you tell the world, hey, here's this flaw, and either have a patch or some other form of remediation. I think coordinated vulnerability disclosure, or CVD, is actually one of the biggest success stories in cybersecurity. And we don't talk about success stories enough, where we can really say, hey, this used to be controversial. Even 5, 6, 7 years ago, this was a big deal. Whereas now everyone's sort of like, yeah, we know that it works pretty well. And now we're worried about making sure it works well all the time. How do we do that? Well, we need to help organizations better work with researchers, make sure they know to acknowledge the issue, engage with researchers constructively, make sure they're providing timely updates as they work for a fix, and stay away from anything that looks like a legal threat. There's a famous phrase where from one of my old friends, Katie Mazuris, involved in coordinated vulnerability disclosure for many, many years. She said, if someone points out that your fly is down, you don't call them a pervert for looking. You thank them and then go fix it. And so that's what we need to do here. Then once we have vulnerabilities, we need to make sure that vulnerability information is of good quality. This isn't always the case, right? We think about CVE records as the way we track vulnerability. Those don't always have the data that we need. So this past year, CISA announced something that we call vulnrichment, where we worked on making sure that the vulnerability records had good information in them, including, right, did they have the right identifiers, CPEs? Did they have CWEs? Did they flag to say, hey, this is this type of risk versus that type of risk? And ultimately, where we want to do is to help make sure that organizations understand which vulnerabilities to prioritize. Remember, the graph at the beginning of the talk showed an exponential rise in vulnerabilities over time. We don't expect everyone to pay attention to every vulnerability. So anything that we can do, CISA, or across the security community to help people prioritize is going to make everyone better off. And the last thing I want to flag to you is not all vulnerabilities actually put people at risk, actually are threats to organizations. I don't want to define the term exploitable because that's a very tricky concept. But there is something that we've been working on called VEX, or the Vulnerability Exploitability Exchange. What this is a machine-readable way of helping to communicate whether or not a vulnerability actually affects the product. Because if you can communicate downstream, yes, there's a vulnerability, but it doesn't affect my product. Therefore, you, the user of my product, the user of my software, whether you're using my open source project in your project, or whether you're a hospital that's using my medical device. If I can say this vulnerability does not affect this product, we're all better off, right? Why might it not affect a product? Could be the component isn't present. I'm worried about log4j. Well, guess what? My software is written in Golang. My software is written in C. So log4j just isn't an issue. Or maybe the affected code isn't in the product. So I'm using OpenSSL, but I'm not using the web server piece, so the Heartbleed vulnerability doesn't affect the product. There are multiple ways why it may not be affected, and the goal here is to communicate that in a machine-readable way so that you can say, you don't have to worry about this. VEX will, we think, really help change how we can help prioritize. So what's the future going to look like? What are we trying to build here with things like VEX, like SBOM? How are we trying to make sure that we're moving it? Well, let's go back to the analogy that I brought at the beginning, building the plane while flying it. So this is not a AI generated image. It's a computer generated image from a commercial in the United States way back in the early 2000s. And it was a company saying, hey, this is a good thing that we're building the plane while flying it. But yet, even inside this ad, they showed that, gosh, if the plane is flying, it doesn't have windows, and someone tries to pour you a drink, you're going to have a bad time. So we need to make sure that while we are creating these new things and encouraging people to use these new things, we need to acknowledge that they won't always work perfectly. So that is going to be the key piece as we think about it. So what's the first step? Well, the first step is better data. Everything that I've talked about is a data layer. But the thing to acknowledge about data is that in and of itself will not help unless you write papers. And don't get me wrong, I used to be a professor. I just wasn't a very good professor, but I was always on the lookout for good data. But good data by itself isn't what we're looking for. We're looking for good data that can support automation. Data into intelligence, into action. And that ultimately is what we're going for, is the idea of automation. Anything we're doing in security in 2024, we're building it without automation, we're doing it wrong. And so we need to make sure that we're keeping an eye on these tools. What does that mean? It means tooling. We need to be able to create this data automatically, and we need to be able to consume this data automatically in a flexible way. So the first step as you look around and think about all of these new data sources that come out is, hey, how could this data be used? And maybe I can build a tool that can actually help, that can integrate it, that can start to glue the pieces together. Because that's the last piece here, is modularity. We want to make sure that things can fit together, and it's not just interoperability, but it's making sure that we can help improve one piece without breaking everything else. So I'll give you a couple of examples. Today, as we think about SBOM, we're thinking about compatibility and harmonization. Something we're doing at CISA in the next few weeks, we're going to have a plug fest, where we're going to invite anyone who's interested in SBOM tooling to bring their SBOM tool to the table. We're going to look at the same piece of software, and we're going to say, hey, the two different tools looking at the same piece of software produce different SBOM. Let's talk about why. Let's think about what can make that, what are the sources, and then unpack that so we're better harmonized at that layer. Second piece, from the modularity perspective, is exploring different identifiers. How do we have a world where we are using PPEs and pearls and something like Omnivore, which contains a lot of intrinsic supply chain data? How do we have a world where all those things can work together without breaking everything? How do we integrate? I'll give you one last example, end of life data. So something that I've been doing a lot of work on independent of SBOM is coming up with ways that we can better handle the risk about end of life. That's not about a vulnerability, right? Something no longer having support doesn't intrinsically mean that it's vulnerable, but it is another type of risk that we need to build into our tooling. So we need to embrace an evolving world of valuable data. More data is going to come online. Trick is not to fight it, but also make sure that we can integrate it into our approach. We'd love for you to get involved in any of these projects that I've described. If you want to reach the CISA team, please reach out at CISA, SBOM at CISA.dhs.gov. We're happy to talk and share more information. We're always happy to have more volunteers. And we're trying to figure out how we can make all of these efforts truly global. So thanks so much for your time. I'm terribly sorry that I wasn't available to join you today, but I'm really looking forward to talking with you some point in the future. Thanks again.